All right, hey AP Chemistry, I got a request to do question number 8, which is the last question from your equilibrium problem set. So I'm going to skip on over to question 8. It's actually a pretty good question to understand. This definitely shows up as multiple choice questions on the AP exam about knowing how to manipulate and rearrange and look at multiple step equations. So it says, consider an equilibrium that occurs in 2 steps. I have H2S aqueous in equilibrium with H plus and HS minus. And then that's step 1. Step 1 definitely has a KC1 because it's an equilibrium. And then it says HS minus aqueous in equilibrium with H plus and S2 minus. And this is going to be, we're going to call that KC2. Okay? Now, A says write the overall reaction. Remember, to write the overall reaction, we add up all of the left side and all of the right side together, and then cross out anything that's in duplicate. So on all of my left reactant sides are H2S aqueous plus HS minus aqueous in equilibrium with, let's see, looks like I have 2 H pluses aqueous, because it's H plus and H plus becomes 2H plus, and then HS minus aqueous, and then S2 minus aqueous. And now, is there anything that's in duplicate on both sides? If I look, I have HS minus is on both sides. And just kind of like an aside, something that's produced in the first step and then used up in the second step, do we remember what that's called? Something that's made and then used up. HS minus, just as an aside, is an intermediate. So just to connect back all the way to Unit 5 in kinetics, HS minus was an intermediate. It's made in the first step and then used up in the second. Anyways, so that's my overall reaction. H2S aqueous in equilibrium with 2H minus plus aqueous plus S2 minus aqueous. All right, and this is going to have its own Kc. We'll just call that Kc, but let's call it Kc3. So it says, how do the Kcs for the 2 steps relate to the Kc of the overall reaction? Now remember from our notes, which I happen to have, if you remember from the last page in our notes, no, not that, not this one, last page in our notes, on page 6, just to reference our notes, it says, if you add 2 or more individual chemical equations to obtain an overall equation, multiply the corresponding equilibrium constants by each other to obtain the overall equilibrium constant. So if I have 2 equations and I add them together, if I want the K of the new reaction, I just didn't put this in our notes as K3. If I multiply K1 times K2, I will get K3. That is what you do when you add equations together. So, how do the Kc's for the 2 steps, Kc1 and Kc2, relate to the Kc of the overall reaction? Well, Kc3, I'm going to call it Kc3, is equal to K1, or C1, times Kc2. If I multiply both these Kc's together, I will get Kc3. Okay? Side note, a trip to Unit 6, delta H's are a little bit differently. If I had like an imaginary letter C, how do the delta H's for the 2 steps, and let's call that delta H1 and delta H2, relate to the delta H of reaction for the overall reaction? And this is just an aside from Unit 6 because we didn't have too much work with that. Kc you multiply together. For delta H's, the delta H of the reaction is just going to be delta H1 plus delta H2. So delta H and K is a little bit differently. For delta H's, if I had a delta H for this one, delta H1, and a delta H for this one, delta H2, adding them together gives me the delta H of the reaction. But If I combine these two and I want the equilibrium constant, I multiply both the KC's to give me K of the reaction. So this is just like a little bit of an elaborate video on how to answer something like question number 8. There was no numbers or math involved. It was just needing to know what to do with the K values to get the overall K constant. Alrighty, hopefully this video was super helpful. This is probably going to be like one of the toughest things to do with manipulating the K EQ expression. So make sure you know how to write overall steps and then recognize how to get your value of K.